buffer system. Now, I'm going to show an example. In a bucket of pure water, I'm going to plot a pH graph. What the pH graph should show in pure water? pH 7. Okay. What if I put some acid in? I put a little bit of acid in. The pH will drop. Maybe pH 5. I put more acid in. May become pH 4. I put more acid in. May become pH 3. Now, that's normal because you put more acid in, the pH will drop lower and lower. Now, I'm going to show a buffer. In case if this solution contains buffer, what will happen? Same story, see how the pH curve should show. Now, I'm going to put some acid in. When I put some acid in, no change, still 7. I put more acid in. I put 20 ml in now, still 7. I put more acid in. Still 7. Now until I put too much, it dropped to pH 4. You will start to ask, hey, what's going on? Is it something go wrong? I put more acid in. Where's the H plus gone? Look like I put more acid in. It just disappearing. I put more acid in and the H plus disappearing until I put too much. Then you will drop. What's going on? Why you will be like that? This is buffer. So you put more acid in, it does not change. Buffer is a solution. It adds to resist change in pH when you add acid or base. So when you add more acid or base into the solution, the pH resists change. It unchanged. It stays the same. When you add acid in, the pH remains unchanged. Then your question will be, how come so magical? Where's the H plus gone? And this buffer, why you will perform this magical? When you put the acid in, they will just disappear. Why? Buffer itself contain, you put in is a weak acid and a conjugate. As you see the way we write a weak acid molecule and equilibrium to become a H plus ion and a negative ion at the equilibrium. That's the way we write weak acid and conjugate base. Imagine when you put more acid in, you increase the H plus ion. What will happen? Le Chatelier principle on equilibrium rule say it will shift this way. Remember the head rule, Le Chatelier principle. So now in this case, this conjugate pair, it will accepting a H plus ion and then become a molecule. Repeat, this conjugate pair will accepting the H plus ion in the solution and become molecule. So you put more acid in, the more molecule will be accepted as H plus ion and disappear. What if you put the base in? When you reduce H plus ion, the molecule will, according to Le Chatelier principle, it will shift that way. Means more acid molecule will become ionized and become H plus ion to compensate. So you put more base in, the pH will not rise up. It will stay the same. So because of the Le Chatelier principle, when you put this substance contain weak acid and its conjugate base, when you put more acid in, it will shift the reverse way. Then when you put base in, it will shift the forward way. That's why it resists change in pH when you add acid or add base. Now let's look closely to this weak acid and its conjugate base. In this table, which ones can work as a weak acid and conjugate base? As what I highlight, ammonia, sodium carbonate, those amphipotic, and all those weak acid, they all have one thing in common. They all have a double arrow. So they all have a double arrow so that they all can use as a buffers in the system. Buffer in biological system. Our body using the buffer system so that to make our body maintain the same pH, so that our pH, the acidity, will not change because of the food you eat or things you drink. It will not changing your pH. So your pH in your body always maintain the same. Here is the system. Let's please look. Carbon dioxide is a gas. It can dissolve in water as an aqueous, but when this dissolved carbon dioxide combine with water, they will form carbonic acid. And carbonic acid is a weak acid that they will ionize H+. So, when your body have too much carbon dioxide built up, and equilibrium will shift towards more carbonic acid will form. Means your body will have more acid, more H plus ion. Your body will start to feel pain and tired. So how does your body cope? Your body will release more HCO3 into your blood. When HCO3 increase, according to Le Chatelier principle, equilibrium will shift the opposite way. So this HCO3 will become accepting H plus as a base. So it will accept H plus ion as a base. So you shift the equilibrium back to become carbon dioxide gas. And then your lung can breathe out carbon dioxide to further reduce carbon dioxide content.